anytime.
Good morning.
Good morning.
My name is Chet Zarniak. I'm a chemical area resource person. I'd like to take a couple of minutes this morning and have you people go around the room and introduce yourselves.
I'm Barbara Braverman. I'm a maintenance engineer here.
I'm Wayne Pembroke, and I'm training foreman in the chemical area, and I've been at DuPont for 24 years.
I'm Annie Marie LaBarber, and I'm in human resource development.
I'm Stan Nelson, and I'm a maintenance foreman.
Oh, really? I meant to mean it the other way.
I'd like to take a couple of minutes this morning to use the same format, go around the room and ask one question and the same question. Do you know why you're here? Barb?
No,
I have no knowledge of why you're here.
my boss told me to come.
Okay. Wayne, do you have any reason or knowledge of why you're here?
We're here because of something to do with train the trainer, so I'm assuming that it's some type of program where we're going to learn how to train people.
Stan?
Well, like Barbara, my supervisor told me to be here, but assuming it's something to do with training, something you're going to train us to do, I would assume.
Annie Marie?
Yeah, they told me training. I like training. I think it's terrific.
Training. Let me tell you why I'm here today. I've been with the DuPont company for about 28 years. In the last 15 years or so, we have had a program to measure the quality of our products. The program started out very simple, and then it grew into an excellent program. It was done very uniformly, and it was very dependable. It was a good system for getting quality control. I too have had grown with this program, and now I am qualified to teach the proper method of conducting a finished product inspection. I would like each of you to have a copy of a formal inspection done recently. I will now go through the procedures with the aid of an overhead projector, and this should enable you to use the format in place to conduct a proper finished product inspection. Please feel free to ask any questions as we go along through the program. First of all, finished product inspections are done bi-weekly by a different operator who is chosen on a pre-determined schedule. So everybody gets involved. With the use of this overhead, I think I can probably show you. First of all, number one, the operator obtains a push cart or a power jack to transport the product to the inspection area. Incidentally, we have an inspection area all set up in the warehouse, and this has all the equipment necessary for doing a complete and thorough finished product inspection.
Chester, why do we do these?
I'll get to that when we get into the session a little further. The operator then obtains no less than 40 to 50 units of finished product from the finished stock area. He is required to inspect about 10 to 12 cubitator put-ups. Now let me explain a cubitator put-up. This is a 5-gallon plastic bladder that fits inside a cardboard container. He also must inspect companion parts, and he counts these as units. A companion part might be a 16-ounce bottle that accompanies a Part A put-up. It might be a 1 quart, it might be a 5-gallon cube that accompanies a 55-gallon drum. So there's various sizes of Part A's and companion parts. The balance will be mostly 5-quart bottles, and generally we take these 5-quart bottles right off the line where the product is being run. The unit should be inverted when taken to the inspection station. The inspection station should be equipped with a scale, digital, hand torque tester, tape machine, knife, and gloves, which I told you earlier that it is. All units should be inspected for weight of material and container versus standard procedure. We have to inspect the torque of the caps. We have to check the liners of the caps for possible wrinkles. We check the proper caps being used for polypropylene, solid hold caps, and foil seal caps. There must be a complete batch number on the carton or the bottle. Parts in the carton must be correct. Cartons have to be clean and undamaged. And all the parts in the liner properly, let me check this, excuse me. And then check to see that the parts in the liner properly are inserts over top of mixer parts and bottles facing each other. What we have here is some bottles face each other, the labels stick together, so we want to make sure they're not facing each other. We have to make sure the tape is secure and the glue seal are strong and tight, and is the seal very neat. Test any product for specific gravity, pH, and check to see that it is in limits. What we do here is we randomly pick a part, we take it into the lab, we take a test sample, and we check to see whether it's within limits, has the right pH and specific gravity. The operator then, when he's done with his inspection, will tape up all the units neatly and return the material to the finished stock area. And we'll write up a report and have it distributed per standard procedure or per the list. We have to maintain a chart for reference, and what we use as a guideline is the torque of a bottle has to be 15 pounds back off torque to be within limits. We have a formula to figure out the percentage of no-go units, and the total of number of units are divided into the units that are okay for customer go, and we come up with a percentage of units that are okay for the customer. We have a worksheet that we use, and the worksheet looks something like this. The date, the product, the size, the batch number, the actual weight, the cap torque, and any remarks the operator cares to put down. When we do a test in the lab, we mark down the test or the product that has been tested. We record the specific gravity and the pH. We also have the finished product follow-up. This is distributed to plant supervisor, Rick Geiger, our clerk. It goes to the 2 shift foremen. It is from the training section, and there's also a date, and it's recorded whether we have customer or plant no-goes. If you look on the right-hand side, you'll see that if action has to be taken in a particular circumstance, then the operators would be notified of their errors. This is what you people have a copy of, and this is a completed FPI. And as you can see, the inspection date was on 8/3. It was conducted by an operator named Kevin Doran. His summary was that he inspected 81 units, 72 bottles, and 9 cubic containers. His remarks were all units inspected were inverted and transported to the inspection area. He had 100% okay for customer complaints. He had 0 leakers, no missing parts. But for our plant quality yield, it was recorded at a 91%. We had 0 customer no-goes, and if you look, you'll see that we had 7 plant no-goes. That's internal. This is his finished product follow-up. This was sent to the shift foreman, area supervisor, from the training office, and these are the remarks. There were 4 24DL5 quart put-ups, no operator's letter or batch numbers. This is just a device that we have internally for telling when the product was manufactured, the month, the date, the batch number. So in case we get a complaint, or a complaint is generated in the field, we can recall this particular batch number. There were 2 put-ups of AP 1 gallon that were low fill. There are limits set, or predetermined limits set, and these did not meet the requirements. And there was 1 XMF Part A 20 gallon put-up that had a low fill. And as you can see, the batch number here was a W7078. This was produced in 1987. The batch number is batch 7, and it's the 8th month of the year. And the operator is W. Now we can go back and see who actually put up this XMF unit and then contact him. This is a copy of the worksheet that the operator used, and he has some comments. He said that no torque because of the new cap being used now, and what I'll explain this is we now have a seal foil cap that goes through, I believe it's ultrasound, and it seals the metal foil to the plastic top, and it generates no leakage generally. So it is a plus for the quality of our products. All products 100% quality. Here's a good remark. All products 100% quality. There were several low fills recorded, and then after that, all the products had 100% quality. The only thing wrong here was some missing letters. It wouldn't normally generate a customer complaint, but we don't like to see that because we have no way of calling the product back. Here's some more follow-up using the worksheet, and as you can see, this whole sheet is recorded okay, and all 100% quality products was produced. So in conclusion, with this information, we can generate a percentage, and we can chart, and we can plot to determine the quality of our product being manufactured. If there is a problem, it can be detected and corrected. We can tell whether we have a problem with packaging, whether we have a problem in our process, whether we have a people problem, or whether we have an equipment problem. This can be dealt with before it becomes a customer problem. That's it.